we have to identify the transformations, graph, and then identify some features about this graph. So let's talk about the transformations first. The first thing I notice if I'm going from left to right is a negative sign. That means that this graph will be reflected. After the negative sign is a 2. That number represents a vertical stretch. And it's a stretch and not a shrink because the number 2 is greater than 1. And then there are two other things. There's this +1 and then this +8. The +1 is in parentheses, so it's actually going to be the opposite direction. So this graph is actually going to be shifted left 1. And then the +8 tells me that this graph will also be shifted up 8. Those last two things we just talked about, the left 1 and the up 8, so this +1 and this 8 here, those represent my vertex. So what I'm going to do is go right down to my table, and I'm going to put -1, 8 inside the middle of my table because that's where you always want to start. You want the vertex to be in the middle of your table, and then we're going to do 2 points above and below. So 2 points below, if I'm just looking at my x values, would be -2 and -3. 2 points above would be 0 and 1. Now, at this point, you have two choices. You can do all of these by hand by plugging it in, and I'll show you how to do that. And then you also have the option of putting this into your calculator and having your calculator give you the table of values. So if you were to do this by hand, I'm just going to do the value of -3. So if I wanted to find f of -3, I would take my function, so -2, and now instead of x, I'm putting in that value of -3. And then the rest of it just gets copied down. From here, you could type this into your calculator, you could do it by hand, but either way you should get that the value comes out to be 0. So that means that the point -3, 0 is on our parabola. All right, so that's how you would do it by hand. You would, of course, have to do it 3 more times for the remaining points. To do it in your calculator, we go to our calculator, you go to y equals, and you type in the exact problem. So we're going to type in -2 parentheses x + 1 squared + 8. And then you see the button that says graph. We're going to press second and then the graph button. And that takes us to our table of values. Now you might have to shift it up or down depending on what you can see. So I want to go here just so I can see a few more points. And you'll notice that I have -1, 8. That's right in the middle. That is my vertex. So it's kind of a nice way to double check that you identified the vertex correctly. And then I already have my x values in, but then you look at, I have these y values, and they're symmetric, and they're supposed to be. So I have a 0 and a 6, and then a 6 and a 0. So I'm going to go back and fill that in. So I have a 0 and a 6, and then a 6 and a 0. So if you had done those by hand, you would have come out with those numbers. So now I'm going to actually plot the points. So I have -3, 0, -2, 6, -1, 8, 0, 6, and then 1, 0. So this is what my parabola looks like. It's an upside down parabola. It's a little bit narrower than a normal parabola because I have that vertical stretch. All right, let's talk about our features. The domain of any parabola is always going to be all real numbers because it will always go forever and ever to the left and the right. The range, because it's upside down, is going to be, all my y values are going to be less than or equal to whatever my highest y value is. And that highest y value here is 8. So my range is going to be everything, all my y values less than or equal to 8. The vertex we already talked about. That's the thing we put in the middle of our table. So that is -1, 8. Axis of symmetry is the line that would cut right through the middle of the parabola. It's always going to be a vertical line, so it will always be x equals. And then it's always going to be the same as the x value of your vertex. So the axis of symmetry for this problem will be x equals -1. X-intercepts are where the graph crosses the x-axis. So I see 2 of them. I see one right here and one right here. And when we're asked for the intercepts, they want the ordered pairs. So I have an x-intercept at -3, 0, and at 1, 0. And you can actually see those values on our table. Here's anytime that you have a 0 as your y value, that's an x-intercept. So these are our two x-intercepts. And then I have a y-intercept, which you can also see on the table. Anytime that your x value is 0, that would be your y-intercept. So that would be this point right here, which is the point 0, 6. And then last but not least, we have our end behavior. So I'm going to put in our automatic x statements as x goes to the left and as x goes to the right. It's actually both going to be the same because if you look at our two arrows here, they're both pointing down. So that means both of our y statements are going to be to negative infinity.